Welcome to this predicted paper from On Maths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our On Maths site. On Maths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! For this question, it's really important that we understand what the words sum and product mean. Now, sum just means add, and product just means times. So we're going to start by adding the 5 and the 4. So that will equal 9. And then what we're going to do is find the product of 9 and 7. So we're going to multiply them together. 9 times 7, which is 63. So our answer is 63. When we simplify a fraction, we want to try and make the numbers at the top and the bottom as small as we can. So looking at the numbers 24 and 60, we need to think, is there a number we can divide both numbers by? Well, they're both even numbers, so we can divide them both by 2. And that will get us 12 over 30. These are also both even numbers, so we can again divide by 2. And that will give us 6 over 15. Now 6 and 15 are both in the 3 times table, so we can divide them both by 3. And we get the answer of 2 over 5. Now 2 and 5, there's no numbers that go into 2 and 5. And so that is our answer. Now we could have gone straight from the question to the answer by dividing by 12. And some of you may notice that 24 and 60 are both in the 12 times table, so you could have gone straight there, but it makes absolutely no difference if you divide by 2, then divide by 3, or you could have divided by 2, then divided by 6, or done it in any of those orders. The first thing we need to work out is the fraction that Sarah will receive. Well, if Jane receives 9 over 10, then that just leaves how much of the numerator to match the denominator. So 9 plus 1 is 10, so it leaves 1/10 left for Sarah to have. And the reason that works is that the total amount needs to add up to 1, and 9 over 10 plus 1 over 10 is 10 over 10, which is just 1. So next we need to find out what 1/10 of 60 is. So we know that we divide by the bottom and times by the top. So 60 divided by 10 is 6. And then 6 times 1 is just still 6. So our answer will be £6. Multiples are times tables. So the multiples of 2 are the times table of 2. So 2, 4, 6, 8, 10, 12, etc., etc. So the only number in this list that is in the 2 times table is the 6. Whenever we multiply two negatives, we always get a positive. So we know our answer will be positive. We're going to do 9 times 12, which is going to be 108, and v times v, which is going to be v squared. Something to realise in this table we're given in this question is that the triangle has 3 sides, quadrilateral 4, pentagon 5, and hexagon 6. And that number is just 2 less than the number of faces. So basically, if you've got the number of sides, you add 2. So 4 plus 2 is 6, 5 plus 2 is 7, and 6 plus 2 is 8. So if we've got 20 sides, and we just do the same thing, so we're just adding 2, then we should have 22 faces. So our answer is 22. So if we just add the amount of sides each of these shapes has, a triangle has 3 sides, quadrilateral 4, pentagon 5, hexagon 6. And notice what's happening with the number of edges. They're multiplied by 3. Each time they're multiplied by 3. So all we need to do is get the 15 multiplied by 3, which will be 45. So there will be 45 edges. For this question, we're going to have to remember BIDMAS or BODMAS. So we're going to first of all look and see if we've got any brackets. Well, we do. We've got the 11 squared minus 21 in brackets, so we're going to be looking at that bit first. Inside the brackets though, we don't have any brackets, but we do have an indice. We've got that 11 squared, so we're going to deal with that first. So 11 squared is 121. So we've got rid of the indice, but we're still looking at the bracket. So we're going to do 121 minus 21, which is going to be 100. Now we have no more brackets, no more divisions, but we do have a multiplication. So it's going to be 300, and that's our answer. This coordinate is telling us to go 2 to the left from the centre. We go right when it's positive, we go left when it's negative, so it's 2 to the right. And then it's telling us to go 1 up. It's up because it's positive, so we need to go 1 up. And we get to the coordinate of B. So the coordinate we get to is B. And so we just look at the -2 on the x-axis and the 1 on the y-axis, and that is where point B is. Congruent means that it's a shape that is exactly the same as another shape, but it can be rotated, translated, can be flipped around, but it's basically the same shape. So I imagine cutting it out onto cardboard and trying to fit it into the other shape. If it can fit, then they are congruent. So looking at the shapes, we've got some triangles, we've got some weird looking shapes, but I'm going to look at A, and I'm going to draw A in. So I'm just going to trace A. And what we can notice is if I manipulate that now, and if I bring it down to E, it kind of almost looks the same as E, but what I can do is actually just reflect it, and it's exactly the same as E. So A and E are congruent. To multiply fractions, all you need to do is multiply the tops. 3 times 7 is 21, and multiply the bottoms. 4 times 11 is 44. We see whether we can simplify this, but actually there's no number that goes into 21 and 44, so it's 21 over 44 is our answer. So what we need to do is find out where the graph is at its highest, and so it's highest here. And so if we go down from there, we find out what year it is. Well, these years seem to be going up in 1, so that's 1950, 1951, 1952. So the answer would be 1952. So the first thing we're going to do is write this as a ratio between the fractions. So we're going to have green to black. Now it says that a quarter of the counters are black, and therefore the remaining counters will be green. So if a quarter are black, that leaves 3/4 to be green. And what we can do here is on both sides of the ratio, what I'm going to do is just times it by 4. So I'm just going to times 4 both sides. So 3 divided by 4 times 4, because over 4 just means divided by 4. So 3 divided by 4 times by 4 just gets rid of the fraction. And 1 divided by 4 times 4 is just going to be 1. Now this might surprise some people because they will probably think it's a ratio of 4 to 1, but we can show here that it's a ratio of 3 to 1. So we have a set of vertically opposite angles here and here. And we're going to start with those because we have to find out what m is before we can work out what x is. And vertically opposite angles are always equal, so we've got 13m plus 39 is going to equal 2m plus 149. And we're going to get our lines in there because we're going to solve this. And to solve this, we first of all take away the smaller amount of m, because we've got m's on both sides. We can't really cope with that when we're solving. And so we've got a 13m and a 2m. So we're going to remove the 2m. We're going to take that away from both sides to start off. And so we're left with 11m plus 39. And we've just got the 149 on the right hand side. Next we're going to remove the number. So take away 39 from both sides. And we've got 11m is equal to 110. and then we're going to divide both sides by 11 to find out what m is. So m therefore equals 10. So we know if m equals 10, we can then work out x. And the way we can do that is the fact that this one and this one are both on a straight line. So they are both on this straight line here. So we know that they've got to add up to 180. So let's write that down. 13m plus 39 plus x is equal to 180 degrees, or I don't normally put that in for the working out, I always put that in for the answer. So we can solve this, or well, first of all, we know what m is, so it'd be 13 times n, which is 130, and then we can solve this. So let's get my solving lines in. And so that's going to be 169 plus x equals 180, and we're going to just take that away from both sides of the 169. So we've got x equals 11. So the value of x will be 11 degrees. So with a stem and leaf diagram, the numbers in the middle often represent tens. They could be units. So we look at the key first of all, and we see that 3 line 9 means 93. So the numbers in the middle are going to represent 10. So this is a 90. Now we're looking for English, so this will be 92. So our first number will be 92. Then this will be 10 tens and a 4. So it would be 104. 11 tens and 1, so 111, and then 11 tens and 2. So to find the median, we go cross out the biggest and smallest until we're left with 1 or 2 in the middle. Here we're left with 2. So what we're going to do is we're just going to add the 104 to the 111, and we're just going to divide that by 2. So when we do that, we get 107.5, or 0.5. So our answer is 107.5. So I think about ratios as piles of money sometimes, and here we've got J getting 5 piles of money and Anne getting 4 piles of money, and each pile is going to be equal. So we've got to first of all work out how many piles of money there are. So we just add the 5 and the 4, so there's 9 piles of money. We sometimes in maths call them parts, so we say that we have 9 parts, okay, or 9 piles of money. Now, each part, oh, I've got an equals there, each part, or each pile, is going to be worth what 99, okay, which is the total amount of money, divided by how many equal piles we have, so divided by that 9. So 99 divided by 9 is 11. So one part is worth £11. So J has 5 piles of £11. So J has 5 times 11, which is 55. And Anne has 4 piles of that money, so 4 times 11, which is 44. We can check this by adding the 2 together, and it should add up to the amount of money we have, which is 99, which it does. For each of these options, try and construct in your head the triangles that would be made from these lengths. And I'm going to give an example for question D, or for option D. And I'm going to construct my triangle just with sticks. So we're going to start off with our first stick, which is 19 centimeters. Then we're going to do another stick, which is going to be 37 centimeters. And we've got one last stick, which is 61 centimeters. Now, looking at the first 2 sticks, the actual combined distance of them, so when we add them together, so be 19 centimeters plus 37 centimeters, is 56 centimeters. So that's the combined width of them. And you can see that that actually wouldn't be able to create a triangle if the third stick is 61 centimeters. So the side here could combine with this side. So we could move this whole stick here onto this side here, but we can't actually make a triangle with it because the two lengths that we've got won't ever reach the end bit here. They just won't ever reach that bit to be able to create the triangle. And I'm just going to put that back. So our answer is option D. All probabilities have to add up to 1. So what I'm going to do is I'm going to take away these probabilities away from 1. So we're going to do 1 take away 0.09 plus 0.13 plus 0.18. And so that's going to be 0.4. 1 take away 0.4 is 0.6. So water to orange is 3-2. Ooh. We've got water here and we've got orange squash here. And we're told that we've got 80 centilitres of orange. So we've got 80 here. And we're asked to find the amount of water required. So what we do is we figure out how to get from 2 to 80. Well, we're going to times by 40. If I times that side of the ratio by 40, I've got to times the left-hand side by 40 as well. 3 times 40 is 120. So I'm going to need 120 centilitres of water. To work out the area of a circle, we first of all need to work out what the radius is. Now the radius is half the distance of the diameter. So to work out what the radius is, we get the diameter and we halve it, which will be 15 centimetres. So the formula for the area is pi times r squared, or pi r squared. If we know the radius is 15, it will be 15 squared. 15 squared is 225. And the way we write this is we put the number first and then we just put pi after it when it asks us to leave it in terms of pi. So it would be 225 pi. Now the reason why we would do this is if we want to keep all the precision, we can do it in terms of pi so we don't have to round it. So we've got to first of all work out how many parts there are altogether. So oil has 21 parts, vinegar has 5, so altogether there's 21 plus 5, which is 26 parts. Now how many of those parts are vinegar? Well, vinegar is the second one, so it's going to be this 5. So vinegar has 5 out of the 26 parts, or a fraction would be 5 over 26. So the rules of indices state that if you have a power inside and outside of a bracket, we just multiply them together. So it's 10 to the power of minus 12 times minus 12. 2 negatives make a positive, and 12 times 12 is 144. Whenever we do these kind of questions, it's always best to convert the pattern into numbers. So we're just going to count the dots. So we've got 2, 4, 6, 8, 9 in the first one. 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So our sequence is going 9, 13, 17. And we're going to see what it's going up in. So we're adding 4 each time, and that means our sequence will involve 4n. And then what we do is we go backwards 1 to find the 0th term. So we're going to take away 1. So 9 take away 1 is 5. So the 0th term is 5. And the 0th term just tells us what to add on to the 4n. So 4n plus 5 will be our answer. Whenever you have north lines, they will always be parallel. So what we have here is we have a straight line going through 2 parallel lines, which are our 2 north lines. And therefore this angle here is going to equal this angle here. And the reason for that is that the 2 angles are alternate, they're Z angles. So we can say that that is 135, and I always like to try and show the examiner the reasons So that's because it's alternate angles. And we know also that angles on a point add up to 360. So this red angle represents the bearing of A from B. And so to find this angle out, what we're going to do is just 360 take away 135. And the reason for that is angles on a point equal 360 degrees. And when we work that out, we get the answer of 225. So our bearing is 225 degrees. The important thing to realise in this question is that we know a female has been selected. So we can just basically get rid of all of this part of the frequency tree because it's not relevant, because we know a female has been selected. So there's 29 females altogether, and we're looking for the probability that the female chosen at random picked action. So it's just simply 16 over 29. A different way of writing this is 1 plus 1/3 plus 2 plus 3/8. So what we can do is just add the 1 and the 2 together to make 3. And then all we need to do then is find out what 1/3 plus 3/8 is. So we're looking for a common denominator between those two. And 3 and 8, if you write out the 3 and the 8 times table, the common denominator is 24, which is 3 times 8. So we're going to times top and bottom of the third by 8, so it becomes 8 over 24. And top and bottom of the 3 over 8 by 3, so that's 9 over 24. Add the tops when the bottoms are the same, so that would be 17 over 24. And then that would just make the answer 3 and 17 over 24. So we're going to first of all work out where 9 is on the y-axis. Well, we've got 8 here and 10 here, so 9 will be halfway in between. And what we're going to do now is just draw a line across at 9, and then wait until it hits the line. And then we're going to draw a line down, and you can see here that x is 1. So our answer is that x equals 1. So in this question we are told that the centre of enlargement is at 6, 4. So let's just put across there. And what I'm going to do is just draw ray lines from the centre of enlargement, and we're just going to go through each of the corners of our shape A. And we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here. And so that would be -4, 1. So to find our new triangle coordinates, what we're going to do is we're going to have a look and see what we have to do to get from the centre of enlargement to each of the corners of A, or the vertices of A. So to get from the centre of enlargement to this coordinate, we go left 2. But it says scale factor 3, so instead of going left 2, scale factor 3 would be 2 times 3, it's going to go left 6. So 2, 3, 4, 5, 6. So the new coordinate for our shape is going to be here. We're going to do the same to the other part. So up, 2, 3, 4. And 4 times 3 is going to be 12. So 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we've got to go left 2 to line it up with our coordinate here. And so we'll go left 6. So what, 2, 3, 4, 5, 6. So our new coordinates here. The bottom right one's just going to be a shared one because it doesn't go anywhere. So we draw in our new shape. And there we go. And it says to label it B, so I'll put a B in it. Okay, so we're going to start by writing this out a little bit bigger, give us a bit more space. So it's -6x is less than 60. And we're going to do our tram lines down. And we're going to start by dividing both sides by -6. because that's what this is doing. It's timesing the x by -6. So I'm going to divide both sides by -6. So that gets rid of the -6 on the left-hand side. And it's going to be 60 divided by -6, which will be -10. Now we've got to be really careful here, because whenever you times or divide both sides by a negative, you must switch the inequality. So instead of pointing to the left, it's now going to point to the right. So our answer is x is greater than -10. To rearrange this, I'm just going to write out the equation again. And I'm going to put my lines in. Okay, so the first thing I'm going to do is try and make the x positive, because we're looking to make x the subject of the formula, which means we need it to be x equals. So what I'm going to do is just add x both sides. So we've got x plus m equals 10. Then we want to get rid of anything on the left-hand side that's not this x. So we want to get rid of this plus m. So we're going to do that by subtracting m both sides. So we've got x equals 10 minus m. So our answer is 10 minus m. X equals 10 minus m. So Pythagoras says that a squared plus b squared equals c squared. And the c is the one opposite the right angle. So I'm going to label this a and b. So it would be 5 squared plus 12 squared equals c squared. 25 plus 144 is equal to c squared, and then 25 plus 144 is 169. And then we're solving to find out what c is, and we're just going to square root both sides. So square root of 169 is 13, so c is 13. So we're going to start off with x equals 0, and we're going to write out this equation, but with 0 every time it says x. So it's going to be y equals 0 squared minus 0 plus 10. Well, 0 squared is just 0, so 0 take away 0 is just 0, plus 10 is just going to be 10. So the answer there would be 10. Do the same for 1. So it would be 1 squared minus 1 plus 10. Well, 1 squared is 1, 1 take away 1 is 0, plus 10 is 10, so that will also be 10. 2 squared minus 2 plus 10. 2 squared is 4, 4 take away 2 is 2, plus 10 will be 12. Now we're going to do the negative, so we're going to look at minus 1. So it's y equals minus 1 squared, and it's going to be minus 1 plus 10. So a little bit more complicated here. Minus 1 squared is just 1. Now here you have two negatives together. When you have two negatives together, it makes a plus. So we've got 1 plus 1 plus 10, which is going to be 12. And then we'll do the minus 2. So it'd be minus 2 squared minus 2 plus 10. So minus 2 squared is 4. The two minuses here make a plus. So it'd be plus 2. Should be 6, plus 10 will be 16. So we're going to plot these on our graph. And so we've got minus 2 is at 16, so that'll be there. Minus 1 is at 12, should be here. 0 is at 10, 1 is at 10, and 2 is at 12. Okay, when you join this up, things to be aware of is you need to make sure that you have a round U at the bottom and not a flat bottom. Okay, so you want to avoid a flat bottom. You also want to make sure that you avoid feathering like that. You want just one nice smooth line. And my recommendation is always to turn the page on its side. I don't have that luxury, so I'm going to try my best with this. But you need to make sure it goes through all the points. And here's the part here where it goes beneath those 2 points. So make sure it goes beneath those 2 points. On most exams, I see them, basically what they do is they draw a line across from those 2 points and say that the line needs to go beneath that, or your curve needs to go beneath that line. So they're looking out that you've gone beneath the line. To answer this question, we need to know what an equation, expression, formula, and identity is. So the formula is basically an equation but for real world things. So area equals pi r squared. It's where the letters actually mean something. Expression is just algebra without the equal sign. So 5x plus 3 would be an expression. An equation has an equals and it can be solved. So you can find out what x is or find out what a is. And an identity is true for all values of that letter. So an example would be x times x equals x squared. That's an identity because that's true for all values of x. So looking here on the right hand side, we've got 3x plus 2x. But if we imagine x is 10, so 3x would be 30 plus 2x would be 20, 30 plus 20, well that will equal 5x, 5 times 10. And actually this is true for all values of x. And the reason it's true for all values of x is we know that 3x plus 2x, this right hand side here, equals 5x. They're the same thing. Now normally with an identity, it's shown with 3 lines. Now in the exam, this type of question, it won't be shown with 3 lines because that kind of gives it away that it's an identity. But this question is definitely an identity. And you can't solve it because it's true for all values of x. So yes, x could be 10, x could be a million, x could be a third, x could be anything. So we're just going to copy this out first of all. So we've got x equals y over 15. Now we're asked to make y the subject, which means we want y on its own. What's stopping y from being on its own? Well, it's divided by 15. That's what over means. It means divide. So how do we get rid of that divide by 15? Well, we do the inverse or the opposite, which is times 15. So we go times both sides by 15. X times 15 is 15x, and it will get rid of this fraction here and just leave y. So y is 15x. So with each of these pools, try and imagine it being filled. So pool A, first of all, we've got water coming into it, and it's actually going to go quite quickly initially, and then it will hit a point at the end where actually it will go really quite slowly because it's a wider pool. So we would imagine that the graph for pool A would actually go quite quickly at the start, and then at the end it would go much slower. And that doesn't really describe, the red graph doesn't really describe that at all. So for pool B, we start off actually quite quickly because it's quite thin, and then we have a wider bit here, so it will go slower here, and then we go quickly again. So we need a graph that starts off quite quickly, then goes slowly, and then goes quickly. And the steeper the graph on our depth time graph, the faster it's filling up. And that red line doesn't really describe that either. Pool C, however, we can see it goes slowly at the start. And then because it's thin, it will go quicker. So nice quickly. And then it will go slowly again. Well, that is a perfect description of the graph that we're given. So the graph we're given is definitely going to be for pool C. The midpoint of a line is just the halfway point of the line, and we can see that the halfway point will be here, and so the coordinates of that point are 0, 2. To find the gradient, we need to find 2 points we know on this graph. So I'm going to pick that coordinate and this coordinate here, and we know that we need to draw a right angle triangle between them, and we find the gradient by the change in y, which is 3, over the change in x. But notice the change in x is 1, so it's going to end up being 3 divided by 1, which is just 3. So a different definition of the gradient is for every 1 we go to the right, how far up we go, which is 3. We can write the equation of all straight lines as y equals mx plus c, with m being the gradient and c being the y-intercept. Now the y-intercept is the nice easy one to find because it's just where the line hits the y-axis, which is at -1, so c is going to be -1. Gradient's slightly harder. What we have to do for the gradient is find 2 coordinates that we know. Well, I'm going to use the same coordinate as I've just found out from the y-intercept, and preferably we want them next to each other, so this one here is a nice one. And the gradient is basically for every 1 we go to the right, how far up we go. And we can see here that we've gone 3 up. So the gradient therefore is 3. And so writing that all out in the equation, it's going to be 3x minus 1. First thing we've got to understand is what a standard form number is. Standard form number is a number between 1 and 10, but not including 10, times 10 to the power of something else. So we've got to find out what these numbers are. So what I'm going to do is just copy down the number we've got. And there's 4 zeros, so 1, 2, 3, 4. And figure out first of all where the decimal point is. Decimal point's always at the end of the number if it's not shown. So we're just going to put that in for later on. So we've got to find out what our number between 1 and 10, but not including 10, is going to be. So I've got to put the decimal point somewhere in this number to make a number between 1 and 10, ignoring the zeros. So I'm going to put it here, 9.9, and that's going to be our standard form number, 9.9 times 10 to the power of something. Next thing I do is work out what the sign of the power is going to be, and it's dead easy. If it's a negative, it's a really small number, so 0 point something. If it's positive, it's a really big number. Well, we've got a big number here, so it's going to be positive. And the last thing I do is count the jumps between our original decimal point and our new decimal point. So 1, 2, 3, 4, 5. So there's 5 jumps, so it's going to be to the power of 5. When we multiply numbers, it doesn't actually matter which order we multiply them. So I can actually rewrite this as 7 times 9 times 10 to the power of 2 times 10 to the power of 9. 7 times 9 is 63. And 10 to the power of 2 times 10 to the power of 9, we add the powers, so it'd be 10 to the power of 11. Now here we've got a problem. It looks like standard form, but it is not standard form. Because standard form has to be a number between 1 and 10, but not including 10. And here we've got 63. So what I'm going to do is just quickly write out what number this is. So we've got the decimal point here. And you don't need to do this, but I find it a bit easier to show what we're doing. So here we've got 10 to the power of 11, so it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We fill these all out with zeros, and that's the number we've created here. A lot of zeros. Now, to make it a number between 1 and 10, not including 10, the decimal point, it needs to be here. So we want that to end up with 6.3 times 10 to the power of, well, let's work that out now. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 10 to the power of 12. Now you don't need to do all the working out I've just shown there. You just need to know when you convert that 63 into a 6.3, you need to add 1 to the power. So the thing we know about triangles is their angles add up to 180. So what we can do is we can say w squared plus 84 plus w plus 3w equals 180. And let's just put that together. So it's w squared plus 4w plus 84 equals 180. Now, with quadratics, whenever we're looking to solve, we want to have it equal to 0. So what we're going to do is we're going to take away the 180 from both sides, so it equals 0. So we've got the w squared plus the 4w, but we want to take away the 180 from it, which will give us minus 96 equals 0. So with quadratics, when we're trying to solve them, we need to put them into brackets. And to do that, we need two numbers that add together to make the 4 here and multiply together to make the 96 here. So just going through different numbers for 96, and you can try different ones. The first letter in the bracket would be W, first thing in the bracket would be W. And I think it's going to be, well, it's going to be a positive and a negative to get that negative there. 96 is 12 and 8, so it would have to be, let's have a think. It'd have to be a positive 12 and a negative 8 to add together to make a positive 4. And 12 times minus 8 is minus 96. That works. And to solve, we look at the left-hand side first and get that equal to 0. So w plus 12 equals 0, and then solve it. So get our lines in. Take away 12 both sides. W equals minus 12. And we get the left-hand or the right-hand side, get that equal to 0. W minus 8 equals 0. Lines in. Add 8 both sides. W equals 8. Now we've got two answers here, but it says value of W. Well, we can't have a negative angle. So we know we're looking for W to be positive. So the answer must be 8. So the way this formula works is we have M, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says, what is the interest rate of the bank? Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. So this question will probably need a Venn diagram just to make it a bit easier. So I'm going to draw a Venn diagram. You don't need to. If you can work out how to do this question without, you can do. But I think this is a really tricky question to do without a Venn diagram. So it says that they picked two activities. It was either painting, which I'll put as a P, and sport, which I'll put as an S. So let's start filling in the information it gives us. So 11 picked painting and sport, so that will go in the middle because that is painting and sport, and 11 didn't pick painting or sport, so they can sit on the outside. Now here's the problem. It says twice as many people picked sport than painting as one of their activities. So it's saying that the total number in let's just show it. The total number in the sports circle is twice as big as the total number in the painting circle. Now, what we can do is we can say, okay, so if the painting we label as X, then the sport will be 2X. But if you look, we've already got a number already in the sport, that 11 there. So in algebra, this will be 2X, take away the 11 that we already know about. And the painting is the same. We know the whole thing is X. So what we're going to do is we're just going to take away the bit we know there, which is the 11, and it will be X minus 11. Now we know that there are 66 students in total. So what we can do now is add up all of the parts of the Venn diagram and get it equal to 66. So X minus 11 plus 11 plus 2X minus 11 plus 11, and all of that will equal 66. This is going to be some solving, so we're just going to put our lines in. Now here we've got X plus 2X, which is 3X. And if I put my tool right, there we are. And we've got minus 11 plus 11, minus 11 plus 11. Well, those just cancel out. So we're left with just the 3x equals, and then 66. I'm going to divide that 3 both sides. So we've got x equals 22. So if we go back to our Venn diagram now, we can fill in the blanks. So instead of x minus 11 there, we've got 22 take away 11, which is just 11. Instead of 2x minus 11 there, we've got 22 times 2, which is 44, take away 11, which will be 33. So it says find the amount that picked sport and not painting, which is this 33 here. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44v to the power 4 w to the power 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11v to the power 4 w to the power 5. Some people will try and do something with the v to the power 4 w to the power 5, but if you think about it, if I just draw out my square, if it's 11v to the power 4 w to the power 5 all the way around, when you add, you don't add the v to the power 4 w to the power 5, it's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power 4 w to the power 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11 v to the power 4 w to the power 5, and we're going to just times it by itself, which is what squaring means. Okay, so we're going to times the 11s together, so that's going to be 121. Going to times the v to the power 4s together, and remember with indices, if you times two powers of the same base, and they're both v, then we just add the powers together, so that'd be 8. And we're going to add the w to the power 5s together, so that makes 10. So it's 121 v to the power of 8, w to the power of 10. When it's said that y is inversely proportional to x, it means that y changes as 1 over x changes. And to write this in an equation, all we do is we just write y equals k over x. Now k is something we need to find. So what we need to do is find out what a value of y and a value of x are somewhere on the graph that would be formed from this, and we've got that in this question. So we know that when y is 7, then x is going to be 7.9. And what I need to do now is just draw my lines down. And what I'm going to do is I'm going to just times both sides by 7.9. And so we have k equals, and it'd be 7 times 7.9, which is 55.3. So we know that k is 55.3. So I'm just going to rewrite this equation here, or this formula here. But instead of k, I know that it's going to be 55.3. So our answer is y equals 55.3 over x. To find the resultant vector, we just get the two vectors and we add the tops and add the bottoms. And it's a plus minus 13, so it's 9 take away 13. When we do that, we get 13 at the top and minus 4 at the bottom. So we're asked to go from B to D. So we're starting at B and going to D. Now we've got a problem here. With B, there are no roads out that we know the name of. We don't know the name of this, we don't know the name of that. What actually we do, two vectors that have the same direction and the same length are the same. So this length here is also going to be P, or the vector is also going to be P. So to get from B to D, we're going to go down this road and then down this road. So the first road was P, second road, we're going backwards down Q, so it would be minus Q. Now for those of you wondering, if we go down this road and this road, it will give us the same vector, because this road here is Q that way, so minus Q plus P is exactly the same. So we need to first of all work out how many black and red counters there are at the start. Now if you look at the fraction of the probability of picking a black, in your first pick is 2 over 5, and then the second pick is 1 over 4. So you can see that there's one less at the numerator and then one less overall. So that means we can conclude that there are 2 blacks at the start, 2 black counters, and if there are 2 black counters and there's only black and red counters, then there must be 3 red counters, so that to make up the fact that it's 2 over 5. Okay, so to find the missing probabilities, the first couple are quite simple because we know that, let's do a different colour, this and this have to add up to 1. And so if the probability of picking a black there is 1/4, then the probability of picking a red must be 3/4, because these have to add up to 1. Same with these two, these have to add up to 1. So if we've got 2/5 at the top, the bottom one must be 3/5. And finally, we've got these two here. Now these two here we're not given any fractions for, but given the fact that we started with 2 black and 3 red, we've picked one of the red, so we've got one less red, and that means we've got 2 black counters and 2 red counters. So it means that the probability of picking a black is 2/4, or 1/2. And the probability of picking a red is 2/4, or 1/2. So the first thing I notice is the second equation isn't really in the normal format for doing simultaneous equations. So I'm just going to rearrange it so that we have it where we want it to be. And I'm just going to put my lines in so I can rearrange. So the first thing I want is the x's and y's on the same side. In fact, actually all I need to do is take away 4y from both sides, and we get 5x minus 4y equals -7. Okay, so what we do now is we put both our equations down so we can solve these simultaneously. So 5x minus 4y equals -7. And you notice the coefficient of the y is already the same, so we don't need to multiply anything. But the signs are different, and the d in different is the d in add. So we're going to add going downwards. So we're going to add everything. So we're doing 3x plus 5x, which is 8x. 4y plus minus 4y is nothing, which is good, because we want to get rid of that. And 47 take away 7 is 40. Alright, let's put our solving lines in. And we're going to divide by 8 both sides. So we get x equals 5. And we're going to substitute that value into one of the equations. I'm going to pick this top one. So instead of 3x, we're doing 3 times 5 plus 4y equals 47. Get my solving lines in. So that will be 15 plus 4y equals 47. And then we're going to take away the 15 both sides. And so it's 4y equals 47, take away 15, which is 32. Divide by 4 both sides. And we get y equals 8. Now we can check that using this equation here. So 5 times 5 is 25. Take away 4 times 8, which is 32, is -7. So we know we've got it right. You can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.